Welcome to this video on interval bisection from FP1. So basically, interval bisection is a way of using approximations to get down to an answer to the required accuracy. So you start with two values, like two whole values, where there's a sign change. Then you go to the midpoint, and the midpoint and one of the values, then look for the sign change, then go to the midpoint and keep on going to the midpoint until you get down to the required accuracy. So when both answers round to the same number of decimal places, for example. It's quite straightforward. It can be a little bit time consuming. Sometimes in the exam they won't ask you to find to so many decimal places. They'll instead say, two approximations or three approximations, give your answer to that. Okay, so this is again going to be another fairly short video, but let's get started then. So here we have our example. Use interval bisection to find the positive root of root 13 to one decimal place. So let's start with let x equals root 13. Therefore x squared will be 13. X squared minus 13 equals 0. So we're looking at f of x equals x squared minus 13. Now for this you just substitute some values in, like f of x, so we can change that value to f of 3, for example. And when I put 3 in, 3 squared minus 13 equals negative 4. F of 4, well, I know 4 squared is 16. 16 minus 13 is 3. So I knew what values it was between 3 and 4 in this case. But some questions you might not know instinctively, so you might have to, take a few more guesses. But this one's obvious because we know it's x squared minus 13, so we know 3 gives me 9 and 4 gives me 16. Okay, so that's where I start. So I've just created a table just to make things a little bit easier, and I filled in the values I've done already between 3 and 4. Now I need to find the midpoint of these two. It's obvious, but add them together and divide by 2 will also give me the midpoint. So 3 plus 4 is 7, divided by 2, 3.5. Okay, then I have to put 3.5 into my f of x to see what the answer is. And that gives me minus 0.75. Okay, so that minus means that 3.5 is minus, and then I've got to compare it or deal with it with the value of a or b, which would have been positive, so the opposite of this sign. So that's the value of b, which is positive. So my answer is going to lie between 3.5 and 4. It wouldn't be 3.5 and 3 because they're both negative. There's no change of sign there. So 3.5 and 4. So then I can put 3.5 in and 4. So this is minus 0.75 and 4 is 3. So now I add 3.5 plus 4, divide by 2, and I get 3.75. Okay, then I put 3.75 into my f of x, and I get a positive value of 1.0625. Okay, so now since this is positive, it must lie between this one and this one. So it's got to lie between 3.5 and 3.75. Okay, so it lies between 3.5 and 3.75. Okay, so now I add those two up and divide by 2. And that gives me 3.625, which then I substitute into f of x, and that gives me a positive value of 0.140625. So it must lie between this one and my 3.5, yeah? Not this one and my 3.75, because they're both positive. So it lies between 3.5 and 3.625. Now at the moment I'm trying to get it to 1 decimal place, and I'm trying to get it so that these two values end up rounding to the same answer to 1 decimal place. At the moment this rounds to 3.6, this one obviously 3.5. Okay, so the midpoint between these two is 3.5625, and then put that into f of x, and I get minus 0.30859 and so on there. So it's a negative value. So this must lie, the root must lie between this value and this value. Yeah, so I'll just put them in my table, although I don't really need to do it in my table any further. But 3.5625, which is minus, and 3.625, which is positive. Now, both of these, this rounds to 3.6 to 1 decimal place, this rounds to 3.6 to 1 decimal place. So now I'm complete. So I can put hence square root of 13 is equal to 3.6 correct to 1 decimal place. And that's it done. So I've used now interval bisection to find root 13 to 1 decimal place. Sometimes the question says, you know, find the first and second approximation. Like in this case, the first approximation would be 3.5, the second approximation 3.75. Okay, we actually got the answer once we got to the fourth approximation there. Okay, so that's all there is to interval bisection. Very easy. I'll give you just a couple of questions to have a go at, and then go through the answers at the end of the video. Now, before you get started into the questions, don't forget to subscribe this video, subscribe to the channel if you haven't done so before, and if you want to help me out, consider becoming a member, even if only for 1 month, 2 months. Just if you feel able and willing to give a little bit back to help me out, then please do so. So here are 2 questions for you to try yourself. Pause the video now and have a go. Okay, straightforward one. So start with let x equals root 17, x squared equals 17, x squared minus 17 equals 0. So f of x equals x squared minus 17. Now, since it's 17, I know it's going to be between 4 squared, 16, and 5 squared, 25. Yeah, so 16 minus 17 is minus 1, and 25 minus 17 is 8. Halfway between 4 and 5 is 4.5. So 4.5 squared minus 17 is 3.25, is positive. So it's between 4 and 4.5, which gives us 4.25. So 4.25 squared minus 17 gives us 1.0625, which is positive again, so it's between 4 and 4.25. So this 4.25 plus 4 divided by 2 is 4.125. Now that squared minus 17 is positive. So it's between 4 and 4.125. So 4.125 plus 4 divided by 2 is 4.0625. Now that squared minus 17 is negative. So it's between 4.0625, which is negative, and 4.125, which is positive. So 4.125 plus 4.0625 divided by 2 is 4.09375. Now this squared minus 17 is negative. So it's between 4.0 Oh, yeah, let me finish this off. Because I've actually got the answer. I actually had it one step earlier. Both of these round to 4.1 to 1 decimal place, don't they? I actually did it there, so I actually had the answer on this line. So I actually had the answer here. Hence root 17 equals 4.1 correct to 1 decimal place. Okay, so both my values of effectively x round to 1 decimal place here. So I actually had it a little bit sooner, but this line would have done it, but this line, oh well, I've done an extra line. Okay, but just goes to show you need to pay attention. I wasn't noticing that 4.09 rounded to 4.1 and 4.125 rounded to 4.1. I was focusing on that 5 there. Okay. So, first part, show that a root of the equation lies in the interval 0 and 1. So, let f of x equals x cubed plus 4x squared minus x minus 1. So we just do this just for terminology, just then we can do f of something, a number, and substitute it in. Okay, it's just a good way of setting things out. So f of 0, first of all, we've got 0 plus 0 minus 0 minus 1. So it's minus 1. And f of 1, we've got 1 plus 4 minus 1 minus 1. So we've got 5 minus 2, which is 3. So therefore, change of sign implies there is a root. Okay. You can also put in, you know, sometimes there is a continuous function, just to, you know, really sell what you are, that you know what you're doing. And, you know, it doesn't work if it isn't a continuous function. Now, use interval bisection 3 times to give an approximation to this root. Now, part B, we know it's between 0 and 1, which give me 3. So 0.5 is going to be my first one. And this is negative 375. So it's between a half and 1. So that's the first interval bisection I've done. So this now is 0.75. And put in 0.75 in, we get a positive value there. So it's between 0.5 and 0.75. So now we've done it twice. So 0.5 plus 0.75 divided by 2 is 0.625. And this is positive. So it's between 0.5 and 0.625. Now dividing them by 2 gives me this, which is negative. So the answer to this is x equals 0.6 to 1 decimal place. So there we have it. I hope you enjoyed this video. I mean, it was very straightforward. I don't know if many people will need to watch this video, to be honest, if you're struggling with this. You know, maybe further maths isn't for you. Or maybe it's just, you know, you're just messing up on these simple things. Anyway, like the video if you found this useful. Don't forget to comment down below. And I look forward to seeing you on the next one. Well, not seeing you, but you know what I mean. Enjoy.